everyone, welcome to my channel. My name is Mr.Adebanjo. I want to welcome you to this video. In this video, we are going to be rubbing minds together on Neco 2025 general mathematics, the theoretical part of the question. That's a promise I've come to fulfilled. In the previous video, I promised that we are going to be discussing this video, and in our previous video, we talked about the objective part of this question. That is to say, if you have not seen that video, please check my channel. You will see the Neco 2025 general mathematics, the objective part of this question, before you come and reference the theoretical part of the question, so that you will not be left out as far as this question is concerned. So in this video, I'm going to be dealing with the theory part of this question. So what are we going to be doing? We are going to be telling you the topic where each of the questions were taken from, and also we are going to be solving each question step by step together. Then also we have 12 questions to solve all together, and we are going to be giving you the step-by-step solution to each of the questions. But before we get it started, please, if you are yet to subscribe to our channel, please click the subscribe button right now on the channel, and so as to help us improve the channel. And also, whenever we post information on this channel, you'll be the first person to know or to be notified. And also, we are appealing to you, please share this video on your social media platforms and all the groups that you belong to. You never can tell, there are people out there who never know about this channel, and they are desperately in need of this video or this resource material to help them prepare for examination like this. So you can help us reach out to them by sharing this video. Whenever you come across this video, please share it. Please share it. We are appealing to you, share it on your platforms so that you help us reach out to them. So without much of our time, let's dive into what we really want to talk about. Now the first question is from percentage error, and the question says that the dimension of a square is given by 6.25 centimeter, and the student measure one of the sides of the square as 6.12 centimeter. To calculate, you have to calculate the perimeter and the area of the square. So calculate a student measure and one of the side of the square to calculate the perimeter and the area of the square. Okay, you have to find the percentage error in the measure length, calculated perimeter, and calculated area. So like I said, question is from percentage error. So that means a student measure a square. So let's represent the square by this diagram. So the square was actually the measure. The side of the square was actually 6.25 centimeter, and we know that when it comes to square, all sides are equal. So that means the length and the breadth are both 6.2 centimeter, 2.625 centimeter. Then the student now measure it. This was the actual length of the square. The student now measured it and got different thing. So he measured it and got 6.12 centimeter as his own square. So that means there's automatically there's an error in the measurement rather. So now what they want us to do is that we have to use this the real and the measure to calculate the error in the length, error in the perimeter, and calculate the error in the area. Now to start with the first one, we have to calculate percentage error in the measure length. So what do? We first need to know the error in the length first. So to calculate the actual length was 6.25 centimeter, and the measure length is 6.12 centimeter. So we need to know the error in length now. Error in length, that will give us a 6.25, which is the actual length, minus the measure length, which is 6.12. Then the error will be 0.13. Then that will enable us to find the error in measure length. So error, percentage error in length will be the error divided by the actual length, which is 6.2 farad multiplied by 100. So that will now give us a 2.06% as the error in length, which is the first one we have to find. Then now we have to calculate the percentage error in perimeter now. Now what we need to do is to first get the perimeter of the actual perimeter of the square with the actual length, then perimeter of the square with the measure length. That's what we need to do. So after getting that, we now find error in that, then we now get percentage error. So perimeter of the actual perimeter of the actual square now, that is to say that the perimeter of the square using the actual length. So how do you find the perimeter of a square? That will be 4 times the one of the length of the square, which will be 4 times 6.25, and that will give us a 25 centimeters. Then we also find the perimeter of the square using the measure length. So perimeter of the square using measure length or perimeter of the measure square, that will be 4 times 1.2 centimeters. We multiply that, give us 24.48 centimeters. So we now calculate the error in perimeter, and that will be 25 minus 24.48, and that should give us a 0.52. Then from there, we will now find the percentage error in calculated perimeter. So that will be the error you got here divided by the actual perimeter of the actual measurement now. So that will give us a 0.52 over 25 times 100. And that will still give us a 2.08% also as the percentage error in calculated perimeter. Then also percentage error in area. The first thing to do is to get the area of the square using the actual length, get the area of the perimeter, the area of the square using the measure length, then find the error, then find percentage error. So also area of the actual square will be 6.25 squared. If you simplify that, give us 39.0625. Then area of the square using the measure length, that will be 6.12 squared. That will give us 37.4544. To calculate error in area now, we have this minus this. That will give us 1.6061. Then percentage error will be 1.6081 divided by the area of the using the actual length multiplied by 100. That will give us a 4.12%. So that's the solution to question number 1. Question number 2a is from the word problem. A factory has 80 employees. If the number of men is doubled and the woman tripled, the staff strength will be 190. Find the initial number of men and women working in the factory. So this is a word problem. So we can say let M represent the number of men and let W represent the number of women. So let M be the number of men and W be the number of women. So we have 80 employees. That means number of men, which is M, and number of women, which is W, will be addition of them will be 80. So that will give us M plus W give us 80. That will give us equation 1. We're now saying that if the number of men is doubled, number of men was M. If it's not doubled, that will give us 2M, and the number of women tripled. Number of women was W. If it's not tripled, that will be 3W. So that addition of them will now give us 190 rather. So that means we'll be having 2M plus 3W give us a 190, equation 2. So we are now to solve the equation 1 and 2 simultaneously to be able to find our M and W. How do we do that? We can use elimination or substitution method, anyone you like, but let's use elimination method here. So let's eliminate M first by multiplying equation 1 by 2 and multiply equation 2 by 1. So multiply equation 1 by 2 and multiply equation 2 by 1. So that we want to do so that we can eliminate M. So if you multiply equation 1 by 2, that gives us a 2M plus 2W equals to 160. You multiply this one by 1, you see how 2M plus 3W equals to 190. So you can now remove equation 1 from equation 2. So that means you have 2M minus 2M, that gives us 0. 3W minus 2W gives us W, equals to 190 minus 160 gives us 30. So that means number of women were 30. Then to find the number of men, we can substitute this into equation 1. So we'll be having the m plus w equals to 80. W was 30, so you have m plus 30 equals to 80. Then m will be equals to 80 minus 30, that gives us 50. So men were 50 and women were 30. So that's solution to question number 2a. Question number 2b, you have to solve the for x in this equation. We have 25 raised to power 3x plus 2 equals to 5 raised to power 2x plus 1, which is a indicial equation. So we have to solve this for x in this indicial equation. So we need to make the base to be equal by finding the index of 25. So that will be 5 raised to power 2 into 3x plus 2 equals to 5 raised to power 2x plus 1. So the base can cancel out the base now, and you expand the bracket here. So we'll be having 2 into 3x plus 2 equals to 2x plus 1. Expand the bracket, that gives us 6x plus 4 equals to 2x plus 1. Collect like time, you have 6x minus 2x equals to 1 minus 4. You have 4x equals to minus 3. S will be equals to minus 3 over 4 if you divide both sides by 4. So that's solution for question number 2. Question number 3a is from the mensuration of solid shape, in this case cone. We are told that the volume of a cone is 565.7 centimeter cube. If the cone is 15 centimeter high, find the base radius of the cone to the nearest whole number, giving pi to be 20 over 7. So we know that volume of a cone is 1/3 of a volume of a cylinder. So we are given the value of the volume. So volume is 565.7 equals to 1 over 3 times 22 over 7 multiplied by r squared, since we are looking for the radius, and the height is 15. From there, if you simplify further, you'll be having 22 times 15 will give us 110 multiplied by r squared over 3 can go in 15, that gives us 5. 5 times 22 gives us 110. Now let's over 7. You can cross multiply there. So 7 multiply this, then we have this. So 7 multiplied by this will give us okay, you can divide both sides by 110. You have r squared to be equal to this. Then if you simplify that further, your r will be equal to 39.99. R squared will be equal to 35.999. If you find the square root of both sides, then r will be equal to 5.99 centimeter. But to leave our answer in the nearest whole number, so to the nearest whole number, r will be equal to 6 centimeters to the nearest whole number. So that's solution to question number 3a. Question number 3b is from the sequence and series, in this case AP. So we are told that the first, second, and the last term of an arithmetic progression is 1, 4 over 3, 3 whole number 2 over 3, respectively. We have to find the number of terms in the AP. So the first term of an AP is A, and that will be equal to 1. So you have A is equal to 1. And we are told that the second term of an AP is 4 over 3. So but the second term of an AP is A plus D. So we have A plus D to be equal to 4 over 3. Then also we are given the last term also, but we are coming back to that. Since our A is 1 and we have A here, so we can substitute the value of our A here. So we'll be having okay, I cross multiply. So if you first of all cross multiply here, 3 will multiply this. So you have 3a plus 3d equals to 4. Your a is 1. If you put that into, you have 3 into 1 plus 3d equals to 4. So that gives us 3 plus 3d equals to 4. 3d will be equals to 4 minus 3 if you collect like times there. So 3d will be equals to 1. Then d will be equals to 1 over 3. Now we know the first term, we know the common difference of the progression now. And we are given the nth term, which is the last term. So the nth term is 3 over 2 over 3. So nth term is same thing as last term. So the nth term of an AP is a plus n into minus 1 multiplied by d. So the nth term of an AP is this formula here. That should be equal to this 3 over 2 over 3, which is changed to improper fraction to be 11 over 3. So our aim is to find the number of terms in the sequence, which is our n. We are looking for the value of n. Our first term is 1, and our common difference is 1 over 3. If we substitute that into this, we have 1 plus n minus 1 multiplied by 1 over 3 equals 11 over 3. So you can clear the denominators by multiplying through by the LCM of 3 and 3. That will be 3. So if I multiply this one by 3, I will get 3 plus open bracket n minus 1. If I multiply this one by 3 as well, that will cancel 1 over 3. That gives us 1 here equals to 11. So 1 will multiply the brackets. We'll be having 1 plus n minus 1 is equals to 11. 3 minus 1 is 2. We have 2 plus n equals to 11. Collect like times n will be equals to 11 minus 2. So n will be 9. So that means we have 9 terms in the sequence. So that's the solution to question number 2b. So question number 3b rather. Question number 4 is on it's from statistics. It's from statistics. You have to the table show the distribution of marks of 60 students in an examination. We have to calculate correct or 2 decimal places, mean and variance. So, like I told you, this question is from statistics, and we are having a group data given. So, what do we do? To find mean of a group data, you have summation fs over summation f. Then, what can we do? We draw the diagram, the table like this. Then our frequency is this. I'm talking about the table given to us. This is how it is. So we need our s. We have f, but we need x to be able to find mean. So how do we find x? S can be gotten from our class interval, which is the mark. So by finding the midpoint of 1 and 10, 11 and 20, and so on. So you add 10 plus 1 together. That gives us 11, then divided by 2. So that gives us 5.5. 11 plus 20 is 31. Divided by 5, that's 15.5. 21 plus 30 is 51. Divided by 5, that gives us 25.5. So you do everything, and that will give us the value of our x. Then we need to find fx. So f will multiply x. So 8 times 5.5 gives us 44. 10.15.5 gives us 155. 8 times 25.5 gives us 104, and so on. Then you need to sum that. That will give us 1730. Then to not get the mean now, mean will not be the value we got, which is summation fs over summation f. That gives us 1730 over 60, and that should give us 28.83 to 2 decimal places for the value of our mean that we have to find. And the variance is calculated by variance of a group data is calculated by summation f into s minus s bar squared over summation f. So we already have our x, which is the value we are having here. Our s is this. Our s bar is the mean that we have gotten here. So we need to compute s minus s bar. So that's the next thing you're going to do on the table. S minus s bar, that will be our 5.5 minus 28.83. That will give us minus 23.33. Then 15.5 minus 28.83. That will give us a minus 13.33. 25.5 minus 28.80. That will give us minus 3.33. Then 35.5 minus 28.83. That will give us 6.67. 45.5 minus 28.83. That will give us 16.67 as well. Having done that, we will now square our deviation. So you square the value you got here, that will be the next thing. So you square this, that will give us this. Square this one will give us this. Square this, it will give us this, and so on. After squaring the deviation, then you now multiply it by the frequency. So frequency here, this frequency will multiply the deviation squared. So that will give us what you're having here. That is to say, 8 multiplied by 544.2889 will give us this. 10 multiplied by 177.689 will give us this, and so on and so forth like that. I haven't gotten that. You now find the summation of that. That means you need to sum this together, and that gives us 10,533.334, which you need to return into this formula. You'll be having that over 60. If you simplify that, that gives us 175.556 to 2 decimal places. You'll be having 175.56 to 2 decimal places. So that's solution to question number 4. Question number 5 is from integration. 5a is from integration of a finite integral or definite integral. Now, you are to integrate a 4s cubed minus 3s squared plus 2dx and the boundary from 3 to 1. So the first thing to do is to integrate this function. So how do we integrate? You add 1 to the, if you integrate a 4x cube here, you add 1 to the power and the power come down. The same thing here, you add 1 to the 2 here and come down. If you integrate 2, you're going to give us 2x, then plus c. So that means we'll be having something like this. You have 4x raised to power 4 over 4 minus 3x cube raised to power over 3 plus 2x plus c. 4 will take care of 4, 3 will take care of 3 here. You have a s raised to power 4 minus s cube plus 2s plus c, and the boundary is from 3 to 1. Now that you have integrated it, now you now apply the boundary. So the upper boundary is 3, so you put 3 in place of x here, minus the lower boundary is 1, so you put 1 in place of s also. So that means you'll be having something like this. So if you simplify that further, you'll be having it 1 minus 27 plus 6 minus open bracket 1 minus 1 plus 2, then c here. So that if you simplify this one here, it's 1 minus 27 plus 6, that will give us 60 plus c. Then 1 minus 1 is 0, then you have plus 2 plus c. If that minus will expand the bracket, you'll be having minus 2 minus c. So c will take care of c here. You have 60 minus 2, that gives us 58, which is the solution to that question 5a. Then question number 5b is on logarithm. We are having that if log 5s minus 6 minus log 2s minus 3 equals to 1, you have to find the value of x. Then this, you are going to apply the loss of logarithm to the left hand side. That should give us a log 5s minus 6 over 2s minus 3, because you're having minus, the minus will change to division, equals to log 10. So log will take care of log. We have 5s minus 6 over 2s minus 3 equals to 10. From there you can take a cross multiply. You have 10 into bracket 2s minus 3 equals to 5s minus 6. Expand the bracket. 20s minus 30 equals to 5 minus 6. Collect times 20s minus 5x equals to minus 6 plus 30. So that will give us 15x equals to 24. Divide both sides by 15. S will be equal to 24 over 15. 3 can go up and down. That will give us 8 over 5, which is the same thing as one number 3 over 5 or 1.6. So that's solution to question number 5b. If you want to know more on logarithm, you can check my channel. There's a video I made on logarithm which can enlighten you more on logarithm. Question number 6 is on matrices. You are given that matrix A and matrix B are these, which are 3 by 3 matrices each. But to find determinant of A and determinant of B. So to find the first one, determinant of A, so we are going to use the first row with their positional sign. So you are going to use the first row of the this matrix, which is 3, 2, 4, and their positional sign. Positional sign of 3 is plus, this is minus, this is plus. They will now reduce this 3 by 3 matrix to 2 by 2 matrix. How do we do that? So the first thing to do is to write 3 with its positional sign, which is plus. So 3, if you having 3, then reduce this 3 by 3 matrix to 2 by 2 matrix. This element is in the first row, first column. Close the first row, close the first column. You will be left with 1, 3, 4, 1. So that means we'll be having a 3, 1, 3, 4, 1, which is after reducing this matrix to 2 by 2. Then you move on to the next one, which is this 2 here. This positional sign of 2 is minus, so you have minus 2. Then reduce this 3 by 3 matrix to 2 by 2. This element is in the first row, second column. So close the first row, second column. You'll be having 3, 3, 1, 1 left, which is what you're having here. Then this also, the positional sign of 4 here is plus, so you have plus 4. Then this element is in the first row, third column. Close the first row, third column. You have 3, 1, 1, 4 left, which is what you're having here. Then what can we do? We are now having determinant of 2 by 2 matrix here to solve. So you have a 3 into bracket. To solve the determinant of 2 by 2 matrix, you cross multiply the diagonals. This diagonal will multiply this diagonal, so you have cross multiply and you subtract. So you have 1 times 1 minus 4 times 3. So we having 3 into 1 minus 12. Then minus 2, 3 times 1, which is 3, minus 1 times 3, which is equal to 3 also, plus 4 into 3 times 4 is 12 minus 1 times 1 is 1. From there, if you simplify further, 1 minus 12 is minus 11 times 3, that is minus 33. 3 minus 3 is 0, that means this one becomes 0. Then 12 minus 1 is 11 times 4, that gives us 44. Minus 33 plus 44 will give us 11, which is determinant of matrix A. The same thing you do for B as well. To find the determinant of B also, you will do the same thing I've done here, but I'm going to be fast with this now. So you need the first row and with their positional sign, and reduce this 3 by 3 matrix to 2 by 2 matrix each. So you have 4 into this. If you go through the same thing I'm going through here, so you understand this. So if you simplify that, you have this, and you'll be having that to be 45, determinant of B to be 45 also. So that is question number 6A. Question number 6B, we have to find the inverse of matrix A. We have to find the inverse of matrix A. This is matrix A here. To find the inverse of a matrix, the inverse of a matrix is adjoint of the matrix divided by the determinant of the matrix. Adjoint of inverse of matrix A is adjoint of matrix A over determinant of matrix A. And adjoint of a matrix is cofactor transpose over determinant of the matrix. So I'm going to take you through the process step by step here. Already we already have the value of determinant of matrix A. That is what we did in the previous slide, because we have to find the determinant of matrix A, and I think we got that to be 11. So we got that to be 11 before, so you can transfer that here. All we need to do is to find the adjoint of matrix A, which is same as cofactor transpose. Then we need to find the cofactor of matrix A now. How do we find cofactor of matrix A? It's very, very simple also. Now, each element in matrix A has what we call minor, which I can call it, let me say, or each element in the matrix A has cofactor, which is called minor. Then how do we find the cofactor of each of the elements here? So we are going to use all the positional sign of the element in matrix A. Remember when we were talking about determinants, we use the positional sign of the first row. But in this case now, for cofactor, we are going to use the determinant. You are going to use the positional sign of all the elements in matrix A, which is like this. This is the sign of all the elements you have here. They have positional sign. So this is positive, negative, positive, negative, positive, negative, positive, negative, positive. So we're going to be using this sign to find the cofactor of each element in this matrix. Now let's start with the first one. So to find the cofactor of A11, which is the element in the first row, first column, which is this 3. So the positional sign is positive. Don't forget to write that. You have positive, so I don't need to rewrite that. Then I'll close the element in the first row, first column, because the element here is in the first row, first column. I have 1, 3, 4, 1, which is what you're having here. And I'll find the determinant of this. That will be 1 times 1 minus 4 times that gives us minus 12. You have 1 minus 12, that gives us minus 11. So that means the minor of 3 is minus 11. I will do it for the element in the first row, first column, which is A12. So the sign of that one is negative, so I'll put negative outside. Then the element of this one is in the first row, second column. Close the first row, second column. I have a 3, 3, 1, 1 left. So I will now find the determinant of that. So I have minus outside. I will cross multiply and subtract. 3 times 1 is 3, minus 3 times 1 is also 3. So that gives us 0. So that means the cofactor of 2 is 0. I'll go to the next one, which is the element in the first row, third column, A13. So the sign is positive. And I will now reduce this to 2 by 2 matrix by closing the first row, third column. I have 3, 1, 1, 4 left. So I have 3, 1, 1, 4. And I will now find the determinant of that. Give us 3 times 4 is 12 minus 1 times 1 is 1. So that gives us 11. Then also I will move to this element here, which is the element in the second row, first column. That will be 821. 821. The positional sign is minus, so I have minus. Then I will reduce this matrix to 2 by 2 by closing the second row, first column. Because the elements in the second row, first column, I'll close it. I have 2, 4, 4, 1 left. 2, 4, 4, 1. I will find the determinant of that as well. So that means I'll cross multiply. 2 times 1 will give us 2. 4 times 4 will give us 16. So I will subtract. So that will give us 2 minus 16 is minus 14. Then minus times 1 will give us plus. So we have 14. I'll move to the next element here, which is positive as positional sign. Then that will be element in the A22. That will be second row, second column. So A22, that will be positional sign is positive. Then I'll close the second row, close the second column. That will give us a 3, 4, 1, 1. I'll find the terminal. That will be 3 times 1. 3 minus 4 times 1 is 4. That will give us a minus 4. Then for the element here, we need to find a cofactor of that as well. The positional sign is negative, and the element in the second row, third column, which is A23, this positional sign is negative. So I will close the second row, third column. I have 3, 2, 1, 4 left. So I will now find the determinant of that will be 3 times 4, 12 minus 2 times 1 will be 2. So that will give us 12 minus 2 is 10. That will give us minus 10 there. Then I'll move to the third column. So I'm right here now. Positional sign is positive, and that element is the third row, first column, A31. So A31, the positional sign is positive, so I don't need to write positive again. So I'll close the third row, first column. I have 2, 4, 1, 3. 2, 4, 1, 3. I'll find the determinant of that. That will be 2 times 3, 6. Then minus 4 times 1 is 4. That gives us a 2. I'll move to the next one, which is the element in the third row, second column. That will be 8, 3, 2. And the sign is negative. So I will have a minus, open bracket, determinant of so I will close the third row, second column. I have a 3, 4, 3, 3. What shall I have in here? Then I'll find the determinant of that as well. 3 times 3 gives us 9, minus 3 times 4 is 12. 9 minus 12 is minus 3. 9 times 1 will give us plus, so we have 3. Then the last one, which is the cofactor of 1, positional sign is positive. The element is the third row, third column. So I will close the third row, close the third column. I have 3, 2, 3, 1. So I have 3, 2, 3, 1. I'll find the determinant of that. That will be 3 times 1 is 3. 3 times 2 is 6. So 3 minus 6, that gives us minus 3. So we have been able to find the cofactor of all the elements in the matrix A. And we'll now bring them together to form the cofactor of matrix A. So if you bring them together like this, you have a minus 11, 0. We have 11. We have a 14. We have minus 1. Then minus 10. We have 2. We have 3. And we have minus 3. So this is the cofactor of matrix A. So we have gotten the value of our C now. So we need to find cofactor transpose. So that means we need to transpose this matrix. So how do we transpose matrix? Is that you change the rows to column or the column to rows. So anyone you want to do, you have transposed it. So let's see. If I transpose this matrix, that means I will change this column to row. Sorry, this row to column rather. As far as I want to do that, I want to change this row to column. So that means I will have minus 11, 0, and 11. That means I've changed this row to column. I will change this row to column as well. That will be 14, minus 1, minus 10. I will change this row to column as well. That will be 2, 3, and minus 2. So that means we have been able to transpose this matrix like that back to the formula. So we now have a cofactor transpose, which is the same as adjoint of matrix A. Then A inverse now will now be equals to the cofactor transpose, which is this matrix, which is written here, over determinant, which is 11. Then I can simplify this one by saying 1 over 11. 1 over 11 multiplied by this matrix here. So you can leave your answer like this, or you can use 1 over 11 to multiply each of the elements inside the matrix. Anyhow, we have been able to find the inverse of matrix what? A. I don't know why Neco is asking this year, because this is meant for further mathematics student, not general mathematics student. But if you want to know everything about matrices, check my YouTube channel. There are 2 videos I made on matrices for general mathematics students and further mathematics students. So there you will see all the topics that are involved in the matrices, and you will learn everything one after the other. Question number 7 is from the quadratic equation. In this case, you have to solve this equation using completing the square method. You have to solve this quadratic template using completing the square method. So you have AS squared plus BS plus C equals 0. So the first thing to do using the completing square method is to make sure that the coefficient of S squared is 1. But in this case, it is A, so we need to divide through by A. So if you divide through by a, you'll be having s squared plus b over ax plus c over a equals to 0. From there, we need to take this constant to the other side. So we'll be having s squared plus bs over a equals to minus c over a. At this point, you cannot complete the square, or yes, you can complete the square at this side. So what do? We need to add, comma, half and square the coefficient of x to both sides. So we are going to add to both sides. What are we adding to both sides? Half and square the coefficient of what? S. So the question is, what is the coefficient of x? That is b over a. So coefficient of s is b over a. So you have to half it. So if you half b over a, what would that give us? That will give us a b over 2a. Then you have to square it again. So that will give us b over 2a all squared. So that is what we are adding to both sides. So we are adding to both sides b over 2a all squared. So if I add it here, I'll be having s squared plus b over x plus b over 2a squared. And I'm going to add it to this one as well. So that means I'll be having something like this now, which I believe this is clear to you. Good. So now, from here now, what can we do? We can simplify this one. Then we change the left-hand side to a perfect square. We can change this left-hand side to a perfect square. And how do we do that? Okay, before we do that, let's simplify this one further. So we still leave it like this. But I would have loved to do it from here, but no forward, so that you can understand what you are doing. Let's leave it for now. We are coming back to this left-hand side. Let's simplify the right-hand side further. So b, this square will affect b. You have b squared. Then the square will affect 2a also. That will give us a 4a squared. So then now you can now change the left-hand side. Let's change the left-hand side to a perfect square. How do we change this left-hand side to a perfect square? That is what you're having here. How can we change it to a perfect square? It is very simple. How do we do that? The variable in this equation is x. So you write your x. Then go back to where you have the coefficient of x. What did you get? You got b over 2a. We got plus b over 2a. That's what we got. I said, how do we go about this? Making this left-hand side a perfect square. The variable in this equation is x. So you write your x. Then go back to when you have x here. What did you get? You said you got plus b over 2a. So that means I'll be having x plus b over 2a all squared. So this is what you're having here, all squared. So this is representing what you're having here now. You have been able to make this a perfect square, which means that if I expand this bracket in two places, I'm going to get this one back. That's what it means. So this is a perfect square of this now, and I believe you understand how we got this. Where the variable in the equation is x, you write x. So whatever you got when you have the equation of x, you got b over 2a. So we got plus b over 2a. So you have x plus b over 2a all squared. Then equals to, you can find the LCM here, which is 4a squared. 4a squared is what you're having here. A in 4a squared, that gives us 4a. 4a times minus c, that gives us a minus 4ac, plus 4a squared in 4a squared, that gives us 1, times b squared, that gives us b squared. Then from here, you can rearrange this one to be b squared minus 4ac. So you'll be having this equals to b squared minus 4ac over 4a. Then from there, what can we do? We can find the square root of both sides so as to get rid of the square here. So I'll be having s plus b over 2a equals to plus or minus square root of b squared minus 4ac over 4a squared. And why are we adding plus or minus? Because we are meant to get two values of x. So that we are adding this plus or minus here. And if you continue simplifying the right hand side here, the numerator is not a perfect square, but the denominator is a perfect square. So you can find the square root of 4 and a square. That will give us 2a. So that means this becomes s plus b over 2a equals to plus or minus square root of b squared minus 4ac over 2a. Before, the square root was covering up and down. Now it's only covering the numerator now, as you can see. Then now this b over 2a will come to this side. You'll be having s is equals to minus b over 2a plus or minus square root of b squared minus 4ac over 2a. So at this point, you can find the LCM of this and this. Because you're having a fraction plus or minus another fraction, you can find the LCM to join them together. The LCM of 2a and 2a is 2a. The LCM of 2a and 2a is 2a. So you'll be having s is equals to divided by 2a. 2a in 2a, that gives us 1. 1 times minus b give us minus b, plus or minus 2a in 2a is 1 times this, that gives us this as well. So when you solve this equation using complete square method, you're going to get this. And this is what we call the quadratic formula or almighty formula. And it was derived using the complete square method to solve the general equation of a quadratic equation. So the next question, we have to use that formula that we got to find the root of this quadratic equation. So our a is going to be 4, our b is 7, our c is minus 2. If you remember the formula that we derived recently, we have this. So you can now substitute that into this equation, into this formula. You'll be having s is equal to our b is 7, so we'll be having minus 7 plus or minus square root of 7 squared minus 4. Our a is 4 and our c is minus 2 over 2 times a, which is 4. So if you simplify that further, we'll be having s is equal to minus 7 plus or minus 7 squared is 49. Then 4 times 4 is 16 times 2, that gives us a 32. Minus times 1 will give us plus, so we have plus 32 over 8. If you simplify that further, we have minus 7 plus or minus 49 plus 32 is 81. We have square root of 81 over 8. And square root of 81 is 9. So that becomes s equal to minus 7 plus or minus 9 over 8. Then from there, we know that this statement implies, it implies two statements. You'll be having s is equals to minus 7 over plus or minus 9 over 8. Okay, I rewrote this again so that to be able to see it here. So this implies two statements. You have s is equals to minus 7 plus 9 over 8, or s equals to minus 7 minus 9 over 8. Minus 7 plus 9 is 2 over 8, or minus 7 minus 9 is minus 16 over 8. You can reduce that to be 1 over 4, or 2 can go in, 8 can go in 16, that gives us a minus 2. So you have s to be 1 over 4, s is equals to minus 2. This is not s is you have s to be minus 2, not s is s minus 2. So this is a typographical error. That is s is equals to minus 2. Excuse me. So that's solution to that question. Then the b part of the question is on the, we have that the mean of 6 number is 40. 3 of the numbers sum up to be 90. What is the mean of the remaining 3 numbers? So this is also a word problem on the statistics as well. We have that let the number be the numbers, all the 6 numbers, let them be a, b, c, d, e, f, for example. So we're having 6 number involved, so their mean is 40. So that means if I add this number together and divide it by 6, that should give me 40. So I should be having a plus b plus c plus d plus f over 6 to be equal to 40. So if I cross multiply, 6 will multiply 40, which means that the addition of all this number will give me that. That is to say that if I have a plus b plus d, 6 times 40 will give us this. So we'll be having that to be 240, which means that if I add all the 6 numbers together, it's going to give me 240. That's what it means literally. We have been told that the 3 of the numbers sum up to 90. So if I assume that the d, e, f are these 3 numbers, so if I sum them together, they say it's 90. I mean, I'm left with a b, c, d. So what does that mean? I'll be having, okay, I said let a, b, c, d to be the 3 numbers, so that sum up to 90 degree to 90. So that means I can replace this one by 90. I'll be left with d, e, f. So I'll be having 90 plus d, e plus d plus e plus f equals to 240. If I collect like times, I'll be having d plus e plus f will be 240 minus 90. That gives us 150. So the sum of the remaining 3 numbers is 150. And because I said what is the mean of the 3 numbers? So that means the mean of these 3 numbers will be the summation of them divided by number of them. So that means how many numbers that I have 3 numbers. So the sum of them is 150. Then to get the mean, I have to divide it by 3. You understand what I'm trying to say? So the mean of these 3 numbers will be 1 over 50. 150 divided by 3 rather. And then that will give us 50. So the mean of the remaining 3 number will be 50, which is the solution to that question also. Question number 8 is a mensuration of a plane shape. Calculate the area of the shaded portion. We are given this shape. We have to calculate the area of this shaded portion. But the issue is that we don't know the name of this shaded portion. But we should be able to know that this is a segment, because the whole shape is a sector, and inside the sector we are having a sorry, this is a full circle. Inside the full circle we are now having a sector, and this is a chord. So inside the chord, inside the sector circle, when you have a chord in a circle, we have a segment. So that is a minor segment here given here. So therefore, the area of the shaded portion, which is segment, is the area of the sector. The whole shape is a sector minus the area of the triangle that we have here. So, and the area of a sector is 360 theta over 360 times pi r square minus area of a triangle with two sides given with an included angle. That will be half r square sine theta. So theta is 54, pi is 22 over 7, and our radius is 8. If you substitute that into this, you have this. And if you simplify this one with your calculator, we have 30.171 minus, simplify this calculator, we have 225.889. If we should subtract, you have 4.282 centimeters squared as the area of the shaded portion, which gives us the solution to question number 8a. Question number 8b is also on the mensuration of solid shapes. A tin of milk has a radius of 6.5 centimeters and a height of 13 centimeters. Find correct to two decimal places the total surface area of the tin and the volume of the liquid in liters that will fill the tin. Pi is 20 over 7. So we know that a tin of a milk is cylindrical in nature. So tin of a milk is cylinder or is cylindrical in nature. And you know that we have different form of cylinders. There's cylinder with open closed ends, that is the two ends are closed, and there's cylinder with a closed end, that is one end is closed, and there's a cylinder with open ends. But when it comes to milk of a tin, sorry, but that's a milk of a tin of a milk rather, we know that the two ends are closed, because when you go to the supermarket to buy a milk rather, when you make it open, you will not buy the milk. That means the ends must be closed. So that means we are dealing with a cylinder with closed ends here now, because we want to find the total surface area of that. So total surface area of a closed end cylinder, that should be area of the two ends that are closed plus the area of the curved surface area. So like I said, total surface area of a cylinder with closed ends, that will be curved surface area, which is 2 pi r h, plus the area of the two ends that are closed. The area of the two ends that are closed is pi r square plus pi r square. So that gives us a 2 pi r square in this case. So that's this formula for finding the total surface area of a closed end cylinder, because tin of a milk is a cylinder with closed ends. So in this case now we can factorize 2 pi r from here, because 2 pi r is common. We have 2 pi r into h plus r. So we can now substitute the value given to us. We are given the value of the radius to be 6.5 and the height is 13. Pi is 20 over 7. So if you put that into this, you have this. If you simplify further, if you simplify this, that will give us 22,286 over 3 times 13 plus 6.5. That will give us 19.5. If you simplify further, that will give us 1,859 centimeters squared, which is the total surface area of the tin of the milk. They have to find the volume of the liquid in the liters that will fill the tin. So the first thing to do is to find the volume in centimeter cube. Then after that, you now convert it to liters. So how do you find the volume of a cylinder? That should be 1/3 over volume of a cylinder. That should be pi r square h rather. So volume of a cylinder is pi r square h. Then if you put your values, you have 20 over 7 times 6.5 square times 13. That will give us 1,726.2 centimeter cube. Then you need to take it to liters, and the conversion rate is that 1,000 liters. Sorry, 1,000 centimeter cube is equal to 1 liters. 1,000 centimeter cube is equal to be 1 liter. So therefore, to convert this one to liter, you need to divide it by 1,000, and that should give us a 1.726 liters. So I think we have to take it to two decimal places. So that will give us 1.73 liters as the volume of the liquid in the milk, in the tin milk. Question number 9 is from bearing. an aircraft took off from a airstrip with an average speed of 35 km per hour on a bearing of 15 degrees for 2 hours. It then changed course and flew on a bearing of 100 degrees with an average speed of 22 km per hour for another 2.5 hours. Find its distance from the starting point to 2 decimal places, the bearing of the airstrip to the nearest degree. So before you sketch the diagram for this, you can see that you are given speed and time. Meanwhile, we need the distance the aircraft covered from the beginning to where it got to before it now changed its course. So we are given the speed and time. So we can use that to find the distance covered by the airplane. So aircraft. Now, how do you find that speed is equal to distance over time? So that we can find distance by cross multiplying. Distance will be equal to speed times time. So let's find the distance covered for the first journey. So the speed was 35 kilometers and the time was 2 hours. So if you put that, so I call the first distance D1. So that will be 35 times 2, that gives us 70 kilometers, that the distance that the aircraft covered. Then also you now change the course and flew on the bearing of this at the speed of 22 km per hour for these hours. So also to get the second distance that they cover, that will be 22 km per hour times the time taken, and time is 2 hours, 2.5 hours, which is same thing as 5/2. So if you multiply 2 can go into it, so that give us 11 times 5, that give us 55 kilometers. That is 55 kilometers as the distance covered. Now that we know the distance that the distances that they cover, so we can now decide and sketch the diagram how it's going to go. So let's go back now and see an aircraft took off from a airstrip. So we need to draw a cardinal point to represent where the origin, where it took off from. So let's draw a cardinal point. Let's say this is the airstrip where the aircraft took off from. So you can call it A. Okay, let's use A to represent the airstrip where it took off from. Then it took off from this airstrip on a bearing of 15 degrees. Bearing of 15 degrees. This bearing is a 3-digit bearing. That means the angle has to start from the north. So on 15 degrees direction. So that means I will draw a straight line here, and then that will be the bearing here will be 15 degrees. And with there, so I will draw a straight line here. This straight line will represent the distance covered, and we have already gotten the distance covered first. That will be 70 kilometers. So after drawing this line, I will draw another cardinal point to represent where the aircraft is currently at. So it's currently here now after drawing this cardinal point, and the distance they cover is 70 kilometers. So you can call this point where it stopped here, you can call it B. So since we are not given the point to use, so you can call it B. So the distance covered is 70 kilometers. So this is where the aircraft is now. So we are now told that it changed its course and flew 100 degrees. So that means it changed its direction. So from here now it changed its direction 100 degrees. And this bearing is also 3-digit bearing. That means it's going to come from the north. So from here to here is 90. That means 100 degrees will fall around here. That means it changes course and travel like this again. So I'm going to draw another straight line here, which represent the bearing of from the north to there. That will be 100 degrees as well. And we should consider that the distance they cover from here to here, which is 55 kilometers, is shorter than the distance there, which should be 70 kilometers. So that means this line should be shorter than this one if you are drawing your own too. So it changes course and it travel again, which is 55 kilometers. And I'm going to draw another cardinal point here also to represent where the aircraft is currently at now, which is here. So I can call that point. I can call that point C. Then from there now, this one is 55 kilometers, which is the distance they covered. Then I can now join this point to the origin, so as to get the full diagram or the triangle that we are meant to get. So can I join this point to this point now? So this is the diagram you have to sketch now, so as to be able to find the distance from the its distance. Where is whose distance? The aircraft, which is here, from the starting point, which is here. We have to find line AC, which the aircraft is here now. then this is the origin. So you are going to find the line AC. Then how do we do that? Before we find this line AC, we need to forward take care of the diagram. That is to say, we need an angle inside the triangle. And where do you think we can get an angle? I think we can get it here inside the triangle. So how? The angle here is 15 degrees, which is alternate to the angle here. So the angle here is 15 degrees as well, alternate angle. Likewise, we can find the angle that is here. Since from north to the south is 180 degrees, and we have already gotten that from here to here is 100. That means from here to here will be 180 minus 100. That will give us 80 degrees as well. So that means the full angle here inside the triangle, that will be 15 plus 80. That will give us 95 degrees. Now that we have an angle inside this triangle, then we have two sides also. Then we can use a principle to find the distance of the aircraft from the beginning, which is line AC. So which principle do you think we can use? We have this triangle given this side and this an included angle. So that we can use a cosine rule. So using cosine rule, you'll be having AC squared equals to 70 squared plus 55 squared minus 2 into 70 times 55 cos 95 degrees. So if you simplify that further, that gives us 4,900 plus 3225. That is square of this plus square of this will give us this. Then 2 times 70 times 55 will give us this. Sorry, 2 times 70 times 55 cos 75 will give us this as well. To simplify this further, that gives us AC squared to be this. To find your AC, you find the square root of both sides. That gives us 92.715 kilometers. So that is the distance. Okay, you have to take that to two decimal places. That gives us 92.72 kilometers to two decimal places. So that's the distance of the aircraft from the origin. Now we have to find the bearing from the S strip to the nearest degree. Find its bearing. Okay, find the bearing of the aircraft from the S strip. Where is the S strip? That is the origin. So we have to find the bearing of this aircraft, which is here, from the S strip. Sorry for that. So that means we are trying to look for the angle this aircraft make from the origin. Can you tell me where the angle is? That should be from the north to the line that join them together. So that means from here to here. We are looking for the angle from the north to the line that join the what's it called? The aircraft from the S strip. So we are looking for the angle from here to here. So that's the bearing of C from A. So we are looking for the angle from the north to this place, which we can get because we already know the angle here to be 15 degrees. So if you can find the remaining angle inside the triangle here, which we can label here, the angle here, we can find the angle here, we can label it theta. You can find the angle here. Whatever we get here, we add it to 15. That will give us the bearing of the aeroplane from the airstrip. So the question is, how can we find the theta here? We can use the sine rule. So we can use sine rule to find theta here, since we already have this side given here. So we can use sine rule. So that will be sine of angle B over the side facing it equals to the sine of theta over the side facing it. So that means you have sine theta over 55. Sine of this angle over side facing, which is sine theta over 55, equals sine 95 over the length of the side facing, which is 92.715. Cross multiply there, you have sine theta will multiply 92.715 equals to 55 times sine 95. We can divide both sides by 92.715. That gives us sine theta equals to this. So if you simplify this with your calculator, that gives us sine theta to be equals to 0.5905. And to find theta, you find the sine inverse of 0.5950. So that gives us 36.23. So that means the angle here is 36.23. So therefore, the bearing of the aircraft from the airstrip will be 15 degrees plus theta, which is 36.23. And that will give us 51.23. So we have to take it to the nearest degree. That will give us 51 degrees to the nearest degree. So let's go back to the 51 to the nearest degree. Then that is the solution to the question for question number 9A. Now I want to tell you that if you really want to understand bearing, there's a video on my YouTube channel whereby I explain everything on bearing from the beginning to the end, and we solve a lot of questions in that video. So it will really help you understand what bearing is all about. So reference the video on my channel where on the title of the video is bearing. So 9b is on differentiation. We have to differentiate this over this with respect to x. So what can we do? We can expand this bracket here, or you can use a quotient rule to differentiate this. Since they didn't say we should use quotient rule, I can use this simple method. I can expand the bracket here. So if you expand, we have a 1 times 1 give us 1. 1 times 2s squared will give us 2s squared. S times 1 is x. S times 2s squared will give us 2s cubed over x. Then there's nothing we cannot collect like times here. So we can break down into different fractions. So 1 over, we are having y is equal to 1 over x plus we'll be having 2s squared over x, that gives us a 2x, plus we'll be having x over s, that gives us 1, plus we'll be having 2s cubed over s, that gives us 2s squared. So from there now, we can now differentiate this now. So we can differentiate y with respect to x, or if ever convert this one to an index form. So that gives us y is equal to s raised to power minus 1 plus 2s plus 1 plus 2s squared. So if you differentiate this now, minus 1 will come to the front. You will remove 1 from the power also. So we'll be having the y ds to be equals to minus s raised to power minus 2. If I differentiate 2x, that gives me 2. If I differentiate 1, which is a constant, that gives me 0. If I differentiate 2s squared, 2 will come to the front here. You have a 4. Remove 1 from the power, you have a 4x also. So if you simplify that further, that will give us 4x. Then if you change this one back to fraction, that gives us a minus 1 over s squared plus 2. So that's the solution to that question also. Question number 10a. Question number 10 is from construction. We are to use a ruler and a pair of compass only to construct a triangle PQR such that PR is 8 cm, angle RPQ is 120 degrees, and angle PQR is 30 degrees. The locus L1 of point equidistant from P and Q. Then you have to find the locus L2 of point equidistant from line PQ and line PRs, which passes through the triangle PQR. You have to label the point where L1 and L2 intersect as X and measure QS. So this construction, so I'm not going to be using a compass and a ruler here, but you're going to be doing that for me. But I'm going to be telling you what to do as I will be demonstrating it on the screen right now. The first thing to do is, first of all, sketch the diagram so as to see how it's going to go. So if I sketch the diagram, it's going to go like the diagram is going to go like this. Just sketch it with your pencil. I have a triangle PQR. So there is side PQ. This is side PQ here. Then there's an angle 120 degrees. So which is at P. So there's an angle 120 degrees here. Will be at P. So there's an angle 30 degrees as well at Q, which is 30 degrees here. So this is how the diagram will go after constructing it. Now let's start with the construction now, so as to see how it's going to go. So I have a line PQ, which is like the line PQ here. So I'll draw a straight line. First, I'll draw a straight line here with my ruler and pencil. So I will now get my compass, then put my pencil in my compass and tighten the pencil very well with the compass and make sure that it is not free, that it cannot remove, and tighten my compass very well so that it will not be losing and closing anyhow. Then place my compass on my ruler. Place my compass on my ruler. Let the pin of the compass be at point 0 and extend the compass to until you get 8. So after getting it, then remove your compass from your ruler. Then put your compass around the pin of your compass around here, and let the pencil be around here. I mean the pencil of the compass be around here. So pin should be here, the pen should be around there. So use the pencil to make an arc on the straight line here. So I should be having something like this here. Then remove the pin from here, put the pin here also, and make your pencil to make an arc here also. So okay, I label this on P. So put your pin here and make an arc here with your pencil. So you'll be having another arc here. you can label it Q. So that means this distance from here to here is 8 centimeters. So which is, you need to label 8 centimeters. So like that, you have been able to make a straight line which is PQ 8 centimeters. I believe you have done that now. Then having done that, we need to make an angle at P, which is labeled angle RPQ. So we need to make an angle here, and we also need to make an angle at Q here, which is labeled angle PQR, which is 30 degrees as well. Now let's start with the first one, which is angle 120 degrees at this place. So 120 degrees is a angle that you can construct with your compass. So what do we do? Take your compass again and close the compass to a specific radius that you want. Close it, not too small, not too big. Close it. Then put your pin here. After putting your pin here, then draw a semicircle. So if I draw a semicircle, I'm going to be having something like this now. So I will put my pin here and I will draw a semicircle like this. After drawing the semicircle, don't close the radius of the compass. Don't close the compass, leaving it the way it was. Then put your pin here. So, no, sorry, not put your pin here. You can see where you put your pin here and make an arc here. So, although I can put my pin here, if I put on my pin here and make an arc here, the first arc I make here, that's an angle 60 degrees. So, okay, let's say I put my pin here, I make an arc. So that arc that I make here, that's angle 60 degrees. Then put my pin here again, make another arc here. So I'll put my pin here and make another arc here. Or I'll put my pin here and make another arc here. So anyone you want to do is still the same thing. So put my pin here and make another arc here. So this arc I've made here, that is angle 120 degrees. Because this is 60 plus 60 give us 120 rather. So what do I do? I'll pick my ruler, then my pencil, another pencil, not the one on the compass. I'll put my ruler and I'll put my ruler here and I'll join this point to this point here with my ruler and I'll draw a straight line there. So that is a straight line. That means the angle here is going to be 120 degrees. Are we here? Good. So having done that, I'm to construct angle 30 degrees here as well. So what do? I will take my compass again using the radius that I used to draw this semicircle. I will put my pin here again and I will draw another semicircle again here also. Then having done that, I want to construct angle 30 degrees. How do I do that? I'll put my rule after drawing this semicircle here, I'll put my pin here, I will make an arc here. So if I put my pin of the compass here, I will make an arc here. So the arc that I make here, that is 60 degrees. But I need 30 degrees. So that means I need to bisect this angle 60 degrees. And how do I do that? It's very simple as well. Don't close the compass. Put your pin here, make an arc here. Then put your pin here also, make another arc here. So those two arcs will intersect themselves. So what do? I'll put my pin here, I'll make an arc. Then I'll put my pin here, I'll make another arc here also. Then where these two arcs meet, I'll pick my ruler and join this point to this point with my ruler with a straight line, and I'll draw it up. So that means I should be having a straight line like this now. So that straight line from the point here will pass through here and join it to. So that straight line will extend and join this straight line here. So that means the angle here is going to be 30 degrees that I've constructed, and I have PQ here. That means I can label this point where this line and this line meet. I can label it R. So this place will be R. So that is the triangle that we have to construct. This triangle we are having here, this is it now that we have constructed it here now. Then that means you are done with the Roman figure 1. Roman figure 2 now, we have to find the locus L1 of point equidistant from P to Q and Q. So we have to find the locus of locus is a straight line equidistant from P and Q. So P and Q is a straight line. P joined to Q is a straight line. So when you have to find the locus of a point that is equidistant from P and Q, that means they want you to divide this P line PQ into two equal parts. So you want you to divide this PQ into two equal parts. Then how do we do that? What you do is you know that distance between P and Q is 8 centimeters. So you can measure 8 centimeters again with your compass. So measure 8 centimeters again. Then, or you can put your pin here, extend your compass to this point. That's same as 8 centimeters. Then put your pin here, make an arc up and down. So I'll be having something like this here. Then downwards, I'll be having another arc down here also. Then remove your pin from here, put it here, make another arc here, and make it down as well. So I'll be having it here and down also here. Then after doing that, I will now remove my compass. I will put my ruler here and join this point together with my pencil. So I will draw a straight line there. So that is my L1. I will label it L1. Then let's go to the Roman figure 3. The locus L2 of the point equidistant from line PQ. This line PQ and line PR. This is line PR here. So they want you to find the locus L2. That is, find the locus, then label it L2. What is the locus? Well, the locus is equidistant from line PQ and then line PR. So what does that mean? To find the locus of a point between two straight lines, that means they want you to bisect the angle that the two lines formed. The two straight lines, this line PQ and this line PR, they form this angle 120 degrees, if you agree with me. Line PQ and the line PR, they form this angle 120 degrees, which is correct. And they want you to find the locus of that two lines. That means they want you to divide that angle into two equal parts. So how do we do that? Some of you can say that, okay, I can just join this line like this. Since this angle is 60 degrees, which is half of 120, it is correct also. But that's not the way you have to do it. What do? Bring your compass. What will you do? Open your compass to a specific radius. Anyhow, just open it. Not too big, not too large. Put your pin here. Make an arc here. Make an arc here. So I have an arc here. I have another arc here. Then put my pin here also. I'll mark an arc here. I'll mark an arc here as well. So like this now, this will help us to find the locus of L2. So I can now use my ruler to join this point and this point together with a straight line. So I will join it like this, as you can see. Then I will label it L2. Then after labeling L2 that you have been able to do, so you are now to label where L2 and L1 where they meet, you have to label it X. So that means this point where they meet, this L1 and L2 where they meet, I have to label it X. So I will label it X like that. Then I'm now to measure QX. This is our Q and S. So place your ruler here and here. So measure how the length of Q to S. So with your ruler. Then my own QS give me 4.8 centimeters. So which is the solution to question number 10. Question number 11 is from a graph, is a quadratic graph. You have to copy and complete the table. Y is equal to 2x squared minus 4x minus 3. You have to complete this table, giving this value of our s to be from -2 to 6. Then you have to complete this table. Then if you do that, so this is the equation we are dealing with, 2x squared minus 4x minus 3. Our s is from this -2 to 6. So for the value of y here, you need to complete the value of y here, here, and here also. Then how do we do that? So you need to put the value of your s is -2. You need to put into this formula. So wherever you see x, you put -2, and simplify it, you give out the value of y. So s is -2. You have 2 into bracket -2 squared, -4 into -2, -3. So -2 squared give us 4. Then that give us 2 times 4 give us 8. Then you have your -2 here. You have a -4 times -2 give us 8. So you have 8 plus 8, that give us 16, -3, that give us 15. So that means your y here will be 15. So that, oh, not 15, I have 13, right, rather. Let's see, -2. You have -2 squared, that will give us 4. 4 times 2 is 8. Then -2 here also, that give us a -4 times -2, that give us +8. 8 plus 8 is 16. Sorry. 8 plus 8 is 16. 16 minus 3 is 13. So that gives us 13 here. So you have already been given the value of here to be 3. So when s is 0, you put 0 here. That gives us 0, 0. So you have -3 left. You have -3. When s is 1, you have 1 here. You have 2 times 1 squared -4 times 1 -3. So that will give us, if you simplify, that will give us -5. You have been given this one to be -3. So when your s is 3, you put that here. You have 3 squared. That is 9. 9 times 2 is 18. Then 3 times -4 give us a -12. 18 minus 12 is 6. 6 minus 3 will give us 3. So you have this one to be 3. Then simplify the rest as well. You have this table. So with this table now, you have to use the scale of 2 centimeters to 1 unit to on x-axis and 2 centimeters to 5 units on the y-axis to draw the graph of this equation. So that we are going to do in the next slide. Now, this is what we want to carry out now. We have already completed our table, which is this, and this is the graph you are going to be using to draw the graph, and you have to use 2 centimeters on 1 unit, so 2 centimeters to 1 unit on x-axis, so and 2 centimeters to 5 units on the y-axis. You have to draw the graph of this equation. So what do? You need to draw your axis, y-axis, and x-axis, and you label it using the scale given. Now, we need to draw our y-axis. To draw our y-axis, we need to consider the value of x. I'm not saying that we should use it, but we are going to consider it. How? On the positive negative side of x, we have how many points there? We have a 1, 2. So we have just 2 points there. So that means we can we need to lose like 2.2 centimeters at the 2 boxes at the left hand side here. But we need more space at the right hand side here. So that means I can put my y-axis around here. So I will draw my y-axis around here, since I need 2 boxes for the negative side of x, but I need like 6 boxes for the positive side of x. So that means I will put my y-axis here and I will label it y. And on the y-axis, we are supposed to put, okay, okay, let's draw our x-axis first. So for x-axis, to draw my x-axis, I will consider the value of y. Where do I need more points on the y-axis? I need more points on the positive side of y. I need more points at the top than down. So I need more points here, or more space up here than down. So that means I can put my x-axis around here. So I can put my y-axis around here. So now, having drawn my x-axis as well, I can now label it now. So for the y-axis, we are told that 2 centimeters represent 5 units. So that means we have 5, 10, 15, and so on like that. So I have 5, 10, 15 to 45. Then on the negative side, we have minus 5 here. Then on the x-axis, we have to use 2 centimeters represent 1 unit. So I will have 1, 2, 3, and so on like that. Then on the negative side, I have minus 1, minus 2, and minus 3, and so on like that. So I'll be able to label my axis correctly. Then I will now need to plot the graph now. But before I plot, I will need to know what one broken line will be on the x-axis and what one line will be on the y-axis. So on the x-axis, we have that 2 centimeters represents 1 unit, and in between 2 centimeters we have 10 lines. So that means one line will be 0.1. How do you get that? That will be 1 divided by the number of lines there, which is 10. So 1 divided by 10 will give us a 0.1. So that means we'll be able to plot. Then also on the y-axis, 2 centimeters represent 5 units, and we have 10 lines then also. So 10 lines carry 5 units. So that means one line will be 0.5, because 5 divided by 10 will give us 0.5. So that will enable us to plot all the points successfully. Now let's start. When our x was minus 2, y was 13. So y was 10 here, so 13. So each line is 0.5. So that means we need like 6 more lines. So we have a 1, 2, 3, 4, 5, 6. So around 6 line here. We'll put an asterisk there. That gives us 13. So when our x was minus 1, our y was 3. So minus 1 is x, 3, y was 3. So that means we need a small line. We need to count 6, because one line is 0.6 also. So it's 0.5 rather. So that means we need 6 lines here. So our asterisk should be around here also. Then when our s was 0, which is on the y-axis, our y was minus 3. So minus 3 also on the y-axis. So that will be, we need more 6 line also. So I should be having an asterisk here also. Then when y was 1. So when s was 1, y was minus 5. So this is s is minus 1 here, y is minus 5 here. So I should have an asterisk here also. Then when s is 2, y was minus 3. So s is 2 here, y was minus 3 here. So 6 line from the beginning on the y-axis. So we should be having another asterisk here. When s was 3, which is here, y was positive 3. So positive 3 on the y-axis, that will be 6th line. Also, I should be having another asterisk here. Then when s was 4, y was 13. So s is 4 here, y is 13 here. So this is 10. Then from 10 to upward, 6 more line, that give us 13. So I should be having asterisk here also. When y was s was 5, which is here, y was 27. This is 20 here, this is 25, 27. That means I need 4 lines more. So 4 lines more, I should be having an asterisk here. Then when s was 6, y was at 45, which should be around here. So I should be asterisk here. So I will now join this point together using a stick of broom or a French curve. So I recommend a French curve. So by a French curve and join these points together, we have something like this. So we have a curve that we have to draw. So this curve is representing y is equal to 2s squared minus 4s minus 3. Then having done that, then C part, we have to find the roots of the equation 2s squared minus 4s minus 3 is equal to 4, correct to 1 decimal place. So we have to find the root of this equation 2s squared minus 4s minus 3 equals to 4. And don't forget that this left hand side represents this quadratic graph, because this quadratic graph is y is equals to 2s squared minus 4s minus 3, which is similar as what we are having here. So that means y is equals to this. So that means I can replace this one with what? Y. So I can call this one y because y was equals to this. So we can call this y is equals to 4. So that means y is equals to 4, which is a linear equation of one variable. Y is equals to 4. So I'll go to my graph where y is equals to 4. I will draw a straight line there. So y is 4 at this point here, because one line on the y-axis is 0.5. So that means the 8th line here. So I will draw a straight line there on the 8th line. So when I draw a straight line there, that will represent y is equals to 4. Then where that line cut the curve, it cut it here and it cut it here. So I will trace it to the x-axis, trace to the x-axis. That will give us the value of x at those 2 points. So what will I do? I will trace it to the x-axis here, trace it to the x-axis here. Then I will now read the value of x here. So at this point, s is equal to 3. So s is equal to 3 here, or here, s is equal to this minus 1. And we know that on the x-axis, one line is 0.1. So you have minus 0.1 minus 0.2. So s is minus 0.1, minus 1.2, or s is equal to 3. So for the value of this is equal to 4, our s is minus 1.2, or s is equal to 3. Then also for Roman figure 2, C2, Roman figure 2, you have to find the gradient of the curve, of this curve at s is equal to 4. So we have to find the gradient of this curve, which is represented by y is equal to 2s squared minus 4s minus 3 at s is equal to 4. So x is equal to 4 here. You have to find the gradient of this curve at that point. What do? You draw a line of tangent to this curve at s is equal to 4. So draw a straight line, which is line of tangent, to be touching this curve at s is equal to 4. Then having drawn that, you will now form a triangle with this line of tangent you have drawn at s equal to 4. You form a triangle with it. So I can draw a triangle here like this. So after forming my triangle here, I'll be able to calculate my change in y over change in x. So we know that the formula for finding gradient is y2 minus y1 over s2 minus s1. So here, at this point here, where this triangle is touching the tangent, at this point here, I will trace it to the y-axis. That will give me my y2. And at this point, where this triangle is touching the tangent, I will trace it to the y. That will give me my y1. So in this formula, I'll be having a y2, that will be 35 minus here 5 over. At this point also, where this triangle is touching the tangent, I'll trace it to the down here to the x-axis. Down here to the x-axis, that give me my s2. So that should be the 8th line there. That should give us a 5.8. Then at this point also, where this triangle is touching the tangent here, I'll trace it to the x-axis as well. That will give me my s1, which should be the 4th line there. That will be 3.4. So that will give us a 5.8 minus 3.4. If you simplify that further, that will give us 12.5 as the gradient of the curve at s is equal to 4. So that is the solution to the graph. Okay, I'm just labeling the graph so that you can see very well. So that's solution to the graph. Question number 12 is from statistics, which is the last question we have to solve for this video. And the question is from statistics. And they show that the table shows the frequency distribution of mark obtained by 50 students in an examination. And we are given a frequency table having class interval represented by mark and frequency. You have to use the table, construct a cumulative frequency table for the distribution. So, and draw the cumulative frequency curve. Now, what do? You have to use this table to construct a cumulative frequency table. Now, what do? I can draw this table like this. So I have the mark, which is representing the class interval, the frequency is here. Then what do? I'm to prepare a cumulative frequency table from this frequency table. This is a frequency table. Then I want to prepare cumulative frequency table. The question is, what can I add to a frequency table to get cumulative frequency table? What do I add to a frequency table to get cumulative frequency table? I will need to add cumulative frequency, and I will need to add upper class boundaries. So I will need to add cumulative frequency and upper class boundary. So yeah, we have cumulative frequency. So how do we cumulate frequency? That means you are adding your frequency together. So what do? The first one here is 3. You have 3 here. So you have 3 plus 5, that gives us 8. 8 plus 8, that gives us 16. 16 plus 11, that gives us 27. 27 plus 9 will give us 36. 36 plus 7 will give us 43. 43 plus 5 will give us 48. 48 plus 2 will give us 50. So we have been able to cumulate our frequency like that. And don't forget, the total frequency here, which is 50, must give us the last value here, which will be 50 as well. So that's how to verify whether you are right or wrong. After you cumulate your frequency, the next thing to do is to find the upper class boundary. Upper class boundary is gotten from the upper class interval. So the upper class interval here will give us the upper class boundaries. So upper class boundary here. So what do? You add 0.5 to your upper class interval to get upper class boundary. So 44.5 plus 0.5 give us 44.5 plus you add 0.5 to this, you have 49.5 and so on like that. So now this is called a cumulative frequency table. This is a cumulative frequency table now that you have had to construct, and that's what we have constructed. Then after doing that, then also to draw cumulative frequency curve that we will draw on our graph. And what do I need to draw cumulative frequency curve? I need cumulative frequency and I need upper class boundary to draw cumulative frequency curve. Let's do that in the next slide. So we will need this graph to draw our cumulative frequency curve. And from our cumulative frequency table, we need this cumulative frequency and upper class boundary to draw cumulative frequency curve. How do we do that? Good. Now, we'll need to draw our axis for this graph. So the y-axis will represent the cumulative frequency, then the x-axis will represent the upper class boundary. So I will need to draw the axis. So I will draw this axis for my cumulative frequency, and which is labeled cumulative frequency, and this place will represent our upper class boundary, which is represented by UCB. Then I will need to label the axis as well. So we can see that the highest number in cumulative frequency here is 50. So I will need to find a scale for my y-axis as well, which is represented by the cumulative frequency. So I have like 10 buses here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 buses. So I should be able to use 2 centimeters, which is representing a box, by 5 units. So 2 centimeters represent 5 units will work here. So I can label it like this. So we have 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Then on your x-axis, which is your upper class boundary, you put your upper class boundary there. You just label it. So we have 44.5, 49.5, 54. Just put your upper class boundary the way it is, like that here. Then from there now we can now draw the cumulative frequency curve. But before we do that, we need to know what one line will be on the y-axis. since we are having 5 units for 2 centimeters, and in 2 centimeters we have 10 lines there. So that will give us 5 divided by 10, give us 0.5 for one line on the y-axis, so that we're able to plot all the numbers here. So let's start. When our cumulative frequency was 3, so 3 on the y-axis, that should be one line is 0.5, that should be 6 lines. Now we need more to get to 3 and under 44.5. So that means I should have an asterisk around here. Then cumulative frequency was 8, so that should 5. This is 5. 8 should be how many lines do we need more? We need 3 units more, which should represent 6 lines under 44.9.5. So I should be having an asterisk here also. Then for 16, when 16 we have 15 here. 16 should be 2 more lines after 15. So that means we'll be having another asterisk here also. Then for 27, this is 25. Then 27, that means I need 4 lines more. So that will be under 59.5. So I should be having an asterisk here. Then for 36, this is 35. For 36, I need 2 more lines. So under 64.5. So I have an asterisk here also. Then for 43, this is 40. Then 43. So for 3, I need 6 more lines under 69 points. So I should be having an asterisk here. Then 48, this is 45. For 48, I need 3 more lines here. I need 3 units more, which is representing 6 lines under 74 points. So I should be having an asterisk here also. Then for the last one, which is 50 under 79.5, I should be having an asterisk here also. So then use your broom to join the points together from the origin here, or you use your French curve. You'll be having a curve like this here, which is the cumulative frequency curve you have to draw, called OGIF. So you have to find the median. If you look at the question we are working on, you have to find, after drawing the cumulative frequency curve, we have to find from the graph median. And the median is gotten by n over 2. Our n representing total frequency, which is 50. We have 50 over 2. That gives us 25. So 25th is the position of the median. So what do? Go to your cumulative frequency curve, draw this 25th here, draw a straight line here until it touches the curve, then you bring it down to the x-axis. So I'll draw a straight line here. So it will touch the curve and bring it down as well, so that we'll be able to read the values of here. So that means I'll be able to read the value here to give me the median. And this 54.5 to 59.5, that means the difference between them is 5. Right? Yes, 5. So that means each line will represent what? 0.5 also. So that means I'll be having a median here, so I can read that. So 2 line will be 1. So be like that, I'll be able to know the value of it. So 2 line will be 1. So I have 1, 2, 3, 4. So added to this 54.5, that should give us around 58.5 to the median. For the median, then we have to find the 70 percentile also, P70, which is 70 percentile. That should be 70 over 100, 70% of the total frequency. That's what it means. 70 over 100 times 50, that will give us 35% position. So go to your graph also. Here at 35, you draw a straight line also until it touches the curve, bring it down as well. Then you read the value of here also. So that should give us, if you read the value, that will give us P70 as I label it. And that should give us 3.5. If you count it very well, each line represents 0.5. Then count the number of lines you have there. Whatever you get, they multiply by 0.5. Whatever you get, you add it to 59.5. That gives us 63.5. So the last thing we have to find the mode. We have to calculate the mode of the distribution. So I brought the table that we constructed under the cumulative frequency table. I brought the table so that I can use it to find the mode. So you cannot find mode on the cumulative frequency curve. You can only find mode on the histogram. Since we did not draw histogram, we draw cumulative frequency curve. We have to calculate the mode using formula. So to calculate mode is calculated by L1 plus open bracket changing 1 by changing 1 plus changing 2 over multiplied by C. Our L1 is a lower class boundary of the modal class. Our change in 1 is the frequency of the modal class minus frequency before the modal class. Our change in 2 is frequency of the modal class minus frequency after the modal class. Then C is the class size or class width. So that means all these formula depend on the modal class. The question is, how do we know the modal class? The modal class is the class with the highest frequency, which is this class. So we are working on this class because the highest frequency here is 11. So we are working on the this class. Then what does that mean? We need the lower class band. L1 means the lower class boundary of the modal class. So this is the lower class interval of the this is the lower class interval, this upper class interval. From the upper class interval we got the upper class boundary before, but now we need lower class boundary, so then we are going to get it from the lower class interval. So this is the lower class interval of the modal class we are working on. This is the lower class interval. So to get the lower class boundary we need to remove 0.5 from here. You remove 0.5, so that will give us a 45.5. Sorry, 55.5, 54.5 rather. That gives us 54.5. You remove 0.5 from this, so our L1 will be 54.5 plus change in 1 is the frequency of the modal class, which is 11, minus the frequency before it. That will give us 11 minus 8. So over, we still have the same thing here because this is change in 1, 11 minus 8, plus change in 2 is the frequency of the modal class minus frequency after the modal class, which is 11 minus 9. Then multiplied by the class size, which is the 49 minus 44, or 45 minus 40, or 54 minus 49, or 50 minus 45. So that will give us the class size, which is 5. So if you simplify this one further, 54.5 plus 11 minus 8 is 3, over 3 plus 11 minus 9 is 2, multiplied by 5. If you simplify further, that will give us 3 times 5 give us 15. 3 plus 2 is 5. 15, 5 and 15 is 3. So if you add it together, that gives us a 57.5 as the mode for the distribution. So we have been able to solve all the 12 questions together for this Neco general mathematics of the theoretical part of the question. And I want to believe that you understand that you have learned one or two things from the solution of this video. And before we go, please, if you're here to subscribe to this channel, please click the subscribe button on the channel right now, so as to help us improve this video and the channel. And please, we are begging, for God's sake, please share this video on all the social media platforms that you belong to, and also on the groups that you belong to on the social media. It will help other students who doesn't know about this video or this channel to be aware of this platform, and the video they are looking for, the material they are looking for may likely be on this channel, so as to help them prepare for any exam like this. And then in the next video, I'm going to be talking about the further mathematics part of this video, of this further mathematics of the Neco 2025 further mathematics question. We're going to be solving in the next video, and I will see you in that video. Thank you and God bless you. Bye.